Observe how a suspension bridge distributes the weight of heavy traffic. The triangular trusses lock the steel beams into a rigid formation, preventing the structure from bending or buckling under pressure. This physical strength is the direct result of mathematical laws. By understanding the specific properties of a triangle, we calculate the baseline requirements for structural stability. Today, we are deconstructing the anatomy, angles, and sides of this fundamental shape. Mastering these rules isn't just for exams, it's the logic behind physical architecture. It allows engineers to predict how a structure will handle stress long before the first beam is placed. We will build this understanding systematically, starting with the internal lines that govern balance before using algebra to solve for unknown variables. Whether it's a diagram on a page or a support beam in a skyscraper, every triangle is bound by exact, calculable properties of measurement. A triangle's behavior is determined by its internal anatomy. These internal segments allow us to locate specific points, such as the exact center of balance. In this triangle, a median connects vertex A to the opposite midpoint, dividing a 12-centimeter base into two equal 6-centimeter segments. Drawing all three medians reveals they intersect at one specific point, the centroid, the geometric center of gravity. To measure height, we use an altitude. It's a perpendicular line dropped from a vertex, striking the opposite side at exactly 90 degrees. In an obtuse triangle, this altitude falls outside. You must extend the baseline until it meets the altitude. Distinguishing between the median and the altitude is the first step in correctly identifying the dimensions needed for area calculations. The most fundamental law of triangle geometry is the angle sum property. All three internal angles must sum to exactly 180 degrees. We can prove this by drawing a line through the top vertex parallel to the base. The alternate interior angles from the bottom fit perfectly alongside the top angle to form a straight line, which measures 180 degrees. To solve unknown angles, given angles x, x plus 10, and x plus 20, set their sum to 180. The equation 3x plus 30 equals 180 gives x equals 50. Plugging this back in reveals the internal angles are 50, 60, and 70 degrees. This brings us to the exterior angle property. Any angle formed by extending a side of the triangle is equal to the sum of the two opposite interior angles. In this case, 55 plus 65 equals an exterior angle of 120 degrees. Because internal and external angles are mathematically linked, we can use these relationships to solve for any missing part of the geometric puzzle. Geometry also dictates physical existence. Simply having three lines doesn't guarantee they can successfully connect to form a triangle. According to the triangle inequality rule, the sum of any two sides must be greater than the length of the third side. We can test this with side lengths of 2, 2, and 5. When the two shorter sides rotate inward to connect, they only cover a distance of 4. They cannot bridge the 5-unit gap, making the triangle impossible to form. When a triangle does exist and contains a 90-degree angle, its side lengths are governed by the Pythagorean theorem. In the formula, the two sides forming the right angle are the legs, A and B. The longest side, directly across from the 90-degree angle, is the hypotenuse, C. Consider a 5-meter ladder leaning against a wall, with its base 3 meters away. To find the height, we square the known sides. 25 minus 9 leaves 16. The square root of 16 is 4, so the ladder reaches exactly 4 meters. The Pythagorean theorem and the inequality rule serve as the ultimate verification system, confirming whether a set of dimensions is physically sound and capable of forming a functional structure. You have now deconstructed the primary rules of triangle geometry. Let's review the core properties you'll need for your next application. First, the centroid is the meeting point of medians, while the orthocenter is the meeting point of altitudes. Second, the internal angles of any triangle will always sum to 180 degrees. Third, remember that exterior angles equal the sum of opposite interiors, and for any triangle to exist, the sum of two sides must exceed the third. Finally, for right triangles, use a squared plus b squared equals c squared. To increase your speed during exams, it is helpful to memorize common Pythagorean triplets, like the 3-4-5 ratio we used for the ladder problem. By applying these properties, you have the blueprint to analyze and solve any triangle problem in geometry or engineering.